I am Anil Kumar. Welcome to my series on polynomials. Let me thank all the subscribers and viewers for watching my videos and posting excellent questions. Now here is a request from one of our subscribers who wants to understand how to write a polynomial, especially cubic equation, when the zeros are given to us. So I have taken up 4 examples which should complete this topic in details. Question number 1. Write a polynomial function in factored form whose zeros are at -2, 1 and half and whose leading coefficient is 4. Sketch the graph and describe end behavior. Question number 2. Write a polynomial function in factored form whose zeros are at 0, 2 and 2. There is a difference in first and the second question. You will notice that the two zeros, 2 and 2, are at the same point. Question number 3. Write a polynomial function in standard form whose zeros are at -2, 1 and 2 and whose leading coefficient is -2. Sketch the graph and describe end behavior. This time you have to write the polynomial function in standard form, not in factored form. That means you need to expand it. Question number 4 is, write a polynomial function in standard form with zeros at 0, with 0 at 2 of multiplicity 3 and whose leading coefficient is 5. So there's only one 0, but its order or multiplicity is 3. So it again makes a cubic function. Sketch the graph and describe end behavior. So these 4 questions should give you good practice and the variety you are looking forward to. So let's begin with some very basic concepts on cubic functions first, and then we'll solve these questions. So any cubic polynomial, let's say y, could be equal to ax cubed plus bx squared plus cx plus d. Now the degree of this polynomial is 3, and therefore it is called a cubic polynomial. So this is your cubic polynomial. All cubic polynomials may or may not have 4 terms, but a should not be 0, a could be 1. Now a is called the leading coefficient. A also decides the end behavior of this cubic polynomial. So if a is greater than 0, that means if it is positive, in that case the graph of the polynomial is right up. So let me show you how it should look like. So if a is positive, then the polynomial right up, right? So that is what it is. And always the end behavior opposite ends, so the left side will be going down. So that will be the type of graph. But if a is negative, let me write in a different ink. If a is negative, the leading coefficient is less than 0, that means negative. In that case, the right side will be going down and left side will be up, right? It's kind of flipped like this. So that is how the graph of cubic function is going to be, right? So this is important to understand when you sketch the graph of those functions. Let me also write this equation in factored form. This is the standard form, right? So the equation which I have given you is in standard form. Now in factored form, you could always factor and get something like a times x minus x1, where x1 is the first root, x minus x2, the second root, x minus x3, the third root. Now if you have 3 roots, in that case you expect the graph of the function to be kind of like this. So it's always a smooth curve. End behavior is towards the opposite ends, where these points here are x1, x2, and x3. Now in this particular case, you will find that there are local maximum and minimum. Right? So this point here is called local maximum, and this is your local minimum. Perfect. And in this case, we are assuming a to be greater than 0. Correct? Now the situation could change. You might have a situation where the function could be having just two roots, right? So it could be like x minus x1 times x minus x2 square. Now in that case, since we have a double root here, the graph is going to be different, right? And you may have a situation where there's only one root, that is x minus x1 whole cube. So all the three equations will actually give you a cubic equation. However, their graphs are going to be very different. Now if we have the roots kind of like this, then what do you expect? So for this graph, you should expect something that is of order 2. So a turning point at this end. Assuming this is greater than x1, the graph of this function will be kind of like this. Perfect. Now we are assuming for all these functions that a value is greater than 0 with positive leading coefficient. Now in such cases, if you have x1 minus x1 whole cube, there is a cubic root. The shape of the cubic root is kind of like this. Do you see it is kind of flatter? So that is how the shape of the graph is going to be at the 0 of the given function. Now we'll keep these things in mind while answering our questions. So I hope the concept is clear, right? So let's get back to our questions and answer them one by one. The very first question here is to write a polynomial function in factored form whose zeros are at, so we are given zeros in this case, at x equal to minus 2, 1 and half. Now since these are the three zeros, that is our x1, x2 and x3, we can write the function f of x as equal to a times, now a is important to write, I'll explain you why, x minus this, that brings us 2, right? X minus 1 and x. Now when the root is half, we could have written x minus half also. However, it is important to understand like this. We could have written x minus half. Now we will always avoid zeros, right? In our factor, now every factor should give us a 0, that is the multiplicity of 0. But this is better to write as 2x minus 1 equals to 0. If you multiply by 2, then what you get is 2x minus 1, correct? So 2x minus 1 will also give you a 0 at x equals to half, right? If you solve it, you get x, right? 2x equals to 1 or x equals to half. Does it make sense to you? So in such cases, instead of writing x minus half, we are going to write 2x minus 1. Does it make sense to you? So we are avoiding fractions by writing like this, where a is any real number, right? So that is how you're going to write it. Let's try to sketch this particular function. So if you sketch this function, then there are two possibilities. Well, we are also given leading coefficient of 4. So we are also given leading coefficient of 4. Let's figure out how to get 4 here, right? So if I multiply x, x and 2x, I already have 2x, right? Now, that is kind of very critical. So we get f of x equal to, a should be equal to 2, since 2 times 2 is going to give us 4. It's kind of tricky at this time to take it up like this, but I hope you soon get this. Now, since we have 2x here, perfect. Well, if you would have written half, 4 times half will give you 2. You could think like this, right? Now, we wrote 2x minus 1. Now, if you multiply the coefficients of x, that is to say, when you multiply these terms, what do you get? You get 4x cubed. So you have made this as 4. You get the idea. So you have to take care of this part whenever you are having a root at a point which is a rational number. Perfect. Now let us try to sketch this. So we are given roots at -2, 1 and half. Let's say this is -2 for us. And then we have positive 1 and half. Let's say this is half and this is 1. Since the leading coefficient is positive, we know a is greater than 0. So we have right side up, correct? And all are linear zeros. Multiplicity 1. So the graph will cross like a straight line at these zeros. You understand? So that is going to be the behavior of the function at the x-intercept. So zeros also give you behavior of the function at at x-intercept. So that's the difference between zeros and x-intercept. So now we can connect these points and sketch the graph. Somewhere it will hit the y-axis like this. Now, this is a very critical point to calculate for any of our graph, and that point makes the graph unique. So we have to find what is f of 0. So let me write here itself. F of 0 will be, if I write 0 for x, then I get 2 times. This will be only 2. Then we have -1 times -1. Correct? So we get these two will give us positive 4. So that point is at 4. So that is how we are going to sketch the curve and label. This graph is approximate but fair enough from test point of view. You need to write down exactly what these x-intercepts are. These are at -2, half, and 1, right? That's the origin. So that is how you're going to do such a question. So I hope it is absolutely clear. Perfect. Now let's move on and take question number 2. Write a polynomial function in factored form whose zeros are at 0, 2, and 2. Sketch the graph and describe end behavior. Now, let's do it in further details. We are given zeros at x equal to 0, 2, and 2. Do you see these two zeros are actually at the same point? Perfect. So we have a double zero. So we have two zeros at the same point. So the factor, which is going to be x minus 2, will have order of 2. Right? So this is called multiplicity of 2. You get the idea. So at this point, the curve of the function at the intercept will turn. So because it is even multiplicity, the graph will turn. Right? Now here we are not given the leading coefficient. So we have two scenarios here. So let me first write down the function with these two zeros. So we get the function f of x as equal to a time. So 1, 0 is at x. You could write x minus 1, 0 is at origin 0. And the other one is at minus 2. So, 2. So we get minus 2 whole square. So this is ax times x minus 2 whole square, correct? Now in this particular case, since we are not given the value of a or the leading coefficient, a could be positive or negative, right? So there could be two scenarios. One where a is greater than 0, the other where a is less than 0. Perfect. So based on this, we'll actually sketch two different graphs and describe their end behavior. Does it make sense? Okay. So the very first one here, the zeros are at 0 and 2. So these are, let us say, our zeros. Since a is greater than 0, right side up, right? So, and this is a double 0, right? So it is going to turn like this. Here at 0, it is a linear 0. So the graph for this particular function is going to be kind of like this. Do you see that part? So this is at 2, this is at 0. Now to describe the end behavior, we can say when x approaches negative infinity, y approaches negative infinity. That is this point. And when x approaches positive infinity, y approaches positive infinity. So this is the case when a is greater than 0. However, if a is less than 0, in that case, what happens? In that case, the right side is down, right? So right side is here if a is less than 0. The two zeros we are talking about are at 0 and 2, right? Now here it is going to turn. So this side 0 is going to turn, so it is going to be like this. And this is a linear 0. So it will kind of go like this, have a max minimum value in this case, and then go up. So that is how the other graph will be if a is less than 0, right? So these are the 2 points, and you can write this end behavior as when x approaches negative infinity, y approaches positive infinity. You can see that part, correct? And when x approaches. So, and when x approaches positive infinity, y approaches negative infinity, that is this side. So that is how you could describe the end behavior of the cubic function. So I hope this part is absolutely clear. Now let's move ahead and take question number 3. Write a polynomial function in standard form. So those two were in factored form. Now we have to write in standard form, whose zeros are at -2, 1, and 2. So again, there are 3 different zeros now, and whose leading coefficient is -2. So we are given a as equals to -2. The zeros are at x equals to -2, 1, and 2. All 3 of them are linear zeros. So the function f of x could now be written as a is -2. So let me write -2 here, and with these zeros, I could write as x plus 2, that is for the first factor, x minus 1, the second factor, x minus 2, the third one. Now we need to write the equation in standard form, right? So we need to multiply them. So, we'll first multiply these two terms. It's kind of easier. We'll use the formula, sum and difference, correct? So let me rearrange and then multiply. So we'll do -2 times, first we do x plus 2 times x minus 2, and then the product we'll multiply with -1. So we get -2 times, this is x squared minus 4, right? A square minus b square, x minus 1. Now we'll multiply with this, okay, these terms, distributive property basically. So we get -2 times, let me make square bracket, x squared times x gives us a cubic function, cubic part, and then we have minus x squared minus 4x, and this gives you plus 4 open this bracket, so get minus 2x cubed minus minus becomes plus 2x squared, that becomes plus 8x, and this is minus 8. So that becomes your function in standard form. Now let's try to sketch this and write the end behavior. Zeros are at, let's say, minus 2, 1 and 2. Now since the leading coefficient is negative 2, the right side is going to be down, right? And all of them are linear, so the graph is going to cut like this. You get the idea? So now we can sketch the graph as this. We really don't know where the local maximum and minimum will be from these curves, right? But we are really interested in the end behavior and the x-intercepts, or the zeros in this particular case. But we need to find what is this value, the y-intercept. So let's calculate. So what is f of 0 equals to? So if I write 0 here, I get minus 8. So it is minus 8, and that is a good check. It is on the negative side of y-axis, right? So that is your y-axis, and this is your function, the graph of the function. Perfect. So I hope it is absolutely clear. And now let's write down the end behavior. End behavior really means what happens to the graph when x is approaching two extreme values, which is minus infinity and positive infinity. We can clearly see that when x approaches negative infinity, y approaches positive infinity, and when x approaches positive infinity, y approaches negative infinity. Always, for a cubic function, they are going to be at the opposite ends. Now, since the leading coefficient is negative, right, so that is a is less than 0, right side down. Easy way to remember. So I hope that makes sense. Now we are at the last question, question number 4. I hope all the concepts are absolutely clear. You can now pause the video, answer this question, and then look into my suggestions. Again, we need to write polynomial function in standard form with zeros at 2 of multiplicity 3. So we are given only one 0 at this time, and which is at x equals to 2, order, or sometimes we also say multiplicity, of 3. That really means there is one factor, which is x minus 2, which makes it 0, but is a cubic factor. That's what it is. Sketch the graph and describe end behavior. Also, we are given leading coefficient a as equal to 5, right? So now we can write the function f of x as equals to 5 times x minus 2 whole cube. Now 5 is positive. So to sketch, right side is going to be up. Perfect. So here is the sketch for the same. So right side is up. This is because a is positive. We have a 0 at 2, right? So here, since this is a cubic 0, it is going to, the graph is going to be kind of like this. So you have to be very specific about the nature of the graph at the x-intercept when zeros are given to you. Since the multiplicity is 3 now, it has to be kind of like this. So the graph will go like this. Do you understand? And it's a smooth curve, right? So that is how it is going to be. This point here is at x equals to 2. Does it make sense? Now, let us write down the end behavior. As x approaches negative infinity, y approaches negative infinity, and when x approaches positive infinity, y approaches positive infinity. That is the end behavior. Since the leading coefficient a is 5, means positive basically, so a is greater than 0. You get the point? Here, again, it is very important to figure out what is this y-intercept. So in this equation, if I write x equals to 0, so we get f of 0 as, let me write here, f of 0 as equal to 5 times minus 2, which is minus 10. So this value is minus 10. Perfect. Now that completes the whole sketch, labeled perfectly fine from examination point of view. I hope these 4 examples give you a good idea about writing a cubic polynomial from given zeros and leading coefficients. At times, the leading coefficient may not be given. Then you have 2 options. The leading coefficient could have been positive or negative. Perfect. It is not important to figure out the maximum or the local minimum in our graph, but at this stage, we are looking for end behavior and the behavior at the x-intercepts for the cubic function which we have seen. I hope that helps. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.